Everyone, in this video we are going to look at linked lists and some of the few important operations that can be done on a linked list. For example, how can a linked list be created, how can it be printed in an increasing order, and how it can be printed in reverse order, and how can a node be added at the head of the linked list, at the end of the linked list, and after a specific value in the linked list. Just as we added a new node to a linked list, how can a node be deleted from the head, at the end of the linked list, and after a specific value in the linked list? The first step in creating a linked list is to create the nodes in the linked list, which is done by creating a structure. Before creating a structure of type node, I am providing a new name for struct node as node. And the second step is to create the structure itself with two elements. The first element is of type int, which represents to hold the data of the node. The second element in the structure holds a pointer to the next node, which is of the same type node. Here you can see I have created a class called linked list, and in the class extension I have created a structure called node with two elements. The first element is the data, the second element is a pointer to the next node, which is of the same type node, and there are two pointers, head and current, of type node. Now in the init method, the linked list is getting initialized with 10 nodes. Malloc is used to create the node. Once the current node is created using malloc, the data of the current node is set to the value of 5, and the next pointer of the current node is set to head, and head points to the current node itself. With this technique, the linked list is initialized with 10 nodes using the for loop. Now, let us see how the values in each node of the linked list can be printed in an increasing order, that is, starting from the head node to the end of the linked list. The print method takes in a reference of the head node. Once it has the reference of the head node, it verifies to see if the head node is null, meaning there are no nodes in the linked list. In that case, it simply returns, or else it recurses through all the nodes in the linked list and prints out the data element in each node. It is a good practice to copy the head pointer to a temporary pointer while traversing through a linked list. In case if the head is moved to the end of the list without copying, there is no way to refer back to the previous nodes in a singly linked list. To print the data in the nodes of the linked list, tail recursion is used with the next node. Just like printing the data in each node of the linked list in an increasing order using the head pointer. This method takes in the head pointer, but it prints the data of each node from the end of the linked list. There is only a very subtle difference in printing the data in the nodes of a linked list in an increasing order and to print the data in a reverse order. When you call the function in a tail recursion, the data in the linked list are printed in an increasing order, whereas when the recursive function is called first before the operation is performed, the data in the linked list are printed in the reverse order. Let us now see how nodes in the linked list can be deleted. First, how can the node at the head of the linked list can be deleted? Second, how a node can be deleted if it is at the end of the linked list. Third, how can a node be deleted after a specific value in the linked list? Each of the three delete methods takes in a reference of the head node. The public delete methods calls in each of the corresponding private delete methods with a reference to the head node. To delete a node which is at the head of the linked list, the first step is to create a temporary pointer pointing to the head of the linked list. The second step is to advance the current head node to the next node in the linked list. The third step is to free the head node which is now being pointed by the temporary pointer. Before attempting to delete the head node in the linked list, it is a good practice to verify if the linked list is empty or not. And in this case, if the linked list is empty, this method simply returns. Let us now see how to delete a node if it is at the end of the linked list. Here in this case, the private method is being called with the pointer to the head node by the public delete method. A temporary pointer is used to point to the head node in the linked list, which is also used to traverse until the last but one node. After that, another pointer is used to hold a reference to the last node in the list. The last node is now deleted using the second temporary pointer. Let us now see how to delete a node with a specific value. To delete a node in the linked list with a specific value, the first step is to have a temporary pointer pointing to the head node. After verifying the linked list is not empty, the temporary pointer is again used to traverse through the linked list looking for the target data in each node. Once the node to be deleted is located in the linked list, a second temporary pointer is used to refer to that node. The next node of the first temporary pointer skips the node to be deleted and points to the next node in the list.